4. How about denominator? 2. So 4 is greater than 2. What if I had s to 4? Proper or improper?
It's still improper. It has to be
They're equal.
Equal, improper. If m is equal to n, again we have improper. So now we have improper rational function. So dividing the denominator into the numerator until the remainder is a proper rational function. So we need to divide. I hope you know how to divide. Do you know how to divide numerator by denominator? How?
synthetic division.
What's that?
Like synthetic division.
Yeah, okay, how do you divide? Go ahead, do it. 2 minutes. S to 4 plus 13 times S to 3 plus 66 S to 2 plus 200 S plus 300. And this one is S squared plus 9S plus 20.
Do you remember how to do it? Oh, I see what you're saying. You're saying go and then the next one is something.
11 over 21. 11 and
I mean, I guess you could do that.
What's the remainder?
minus 210 S
I was going to do one more step.
The remainder is
minus 210.
so, okay, let's see.
Here. 30 S plus इकट्ठा 30 हो गया we have it
You have it?
30 S plus 100 30 S plus 100
Okay.
plus minus
Any other student? Okay.
So this is the 1, 3, 1, 2, 3, 4. Just write that.
How about the remainder?
This is S cubed, and this is S.
12 plus 16. Okay. 16. Okay. Sarah?
I think I got 38S plus 180.
30s plus 180. Okay. Okay, let's check your answers.
30S plus 100.
Who got 30s plus 100? Who else?
Ian was 100.
Good.
Yeah.
Bill? Who else? What's your name? Scott. Okay, I'm going to explain it. So S to 4 plus 13 times S to 3 plus 63 times S squared plus 200 S plus 300 divided by S squared plus 9S plus 20. So for the first term, you see over here, and this one, the first term, you see over here. If I multiply it by S squared, I will get S4, S to 4. Is that clear? So I wrote S squared. So S squared times S squared, I get S to 4. S squared multiplied by 9S, I have 9 times S to 3 plus 20 times S squared. Subtract them. Minus, minus, minus. So these two will cancel out, or these two is 2, 4. Minus S to 4 is 0. 13 minus 9 is 4 S to 3. And 66 S squared minus 20 times S squared is 46 S squared. What you have, 200S plus 300. So look at the first term again. It means the one which has the highest order. So if I multiply this square by 4 times S, I will get 4 times S to 3. So 4S multiplied by 9S, 36 times S squared. 4S multiplied by 20 is 80S. Make them negative. 0. 46 minus 36 is 10 S squared. And this one will be 120S and plus 300. So what is this one? 10S squared. So if you multiply this one by 10, you will get 10S squared plus 10 times 9, which is 90 times S, plus 200, negative, negative, negative. This is 0. This will be 30 times S, and this is 100, which is the remainder. Was it difficult? Yara? You got it? Yes? Questions? You have quotient over here. You write it as a square plus 4S plus 10 plus the remainder, which is 30 times S plus 100 over S squared plus 9S plus 20. So again, if you multiply this term by this and sum it, you will get this. Questions? Eric? Clear? So you write this part, whatever you get here, plus remainder over this one.
It's like long division.
It's,
Yeah, it is.
yes, it is. Yes, Josh. minus 20. Let me. Okay, now we don't have any problem with this part for getting the inverse Laplace transform. But this one, which kind of rational function do you see over here? Now you have proper rational function. And which kind of proper rational function? Find the roots. What are the roots? How many roots do you have for this part?
2.
2, because this is square. So what are those roots? Yeah, because I wrote it here. The roots are negative 4 and negative 5. So how do you solve it? This is which kind of proper rational function? This thing? Real. So easy, okay? So minus 20, if you say this is k1 over s plus 4 plus k2 over s plus 5. How do you solve for k1? Again, multiply by the denominator of k1, which is s plus 4, both sides of the equation, and evaluate it at negative 4. For k2, multiply both sides of the equation by s plus 5 and evaluate it at minus 5. So if you do that, that will be you doing at home. Check my answers. This one will be minus 20 and k1 will be minus 20 and k2 is 50. So now get the inverse transform. What is this square? The inverse transform of this square. Last class I explained second derivative of. Okay, what is the Laplace transform of a delta function? Laplace transform of delta function. Do you have the table? No? On bright space. Yeah. So what is the Laplace transform of delta function? S is 1. And what is the Laplace transform of the first derivative of delta function? S. And the second? S squared. So that's why you see this part. Plus 4 times S, the first derivative of delta function, plus 10 times 1, it means 10 times delta function, minus 20 times e to minus 4t, plus times ut, plus 50 times e to minus 5t ut. Any questions? Questions, Omar? No? Clear? Okay, practice assessment problems 12.8 and 12.9. Too noisy class today. What is going on? Any part? If you have questions, you can ask me now. This was that?
We're enjoying the class. It's very fun.
Can you re-explain?
The division?
Yeah.
The first part? Okay, sure. Okay, I'm going to explain how I divide this one by this one. Please, one more time for the student who didn't follow me. Okay. This one divided by this. So the highest order is S4 for this one, and the highest order is S2, okay? You just arrange it like this, from the highest order to the lowest one. And this one the same. So what should be multiplied by S2, which I get S24? What multiply by S2, so I get S24. Your name is? Anika. Okay, so what is X here? S squared. So S squared multiplied by S squared, I will get S24. So that's why I put over here S squared. So S squared multiplied by this divisor, I will get S24 plus 9 times S23 plus 20 times S squared. You just negative the signs. So S4 minus S4 is 0, 13 minus 4 is 4, and 66 minus 20 is 46 S squared, and you have 200S plus 300. You want me to explain more?
No, that's fine.
Okay. Assessment problems 12.8 and 12.9. This part is just a review about poles and zeros. If we have rational functions like this, the roots of the numerator we call zeros and the root of denominator we call poles. Okay, assessment problems 12.8 and 12.9. We have two terms over here. The one is called initial and another one is final value. So the initial value theorem states that if you get limitation limit of f of t when we are in the time domain and when t approaches 0 positive, this will be equal to lim of s times f of s when we are in the s domain when s approaches infinity. And for the final value, lim of f of t when t approaches infinity is equal to lim of s times f of s when s approaches 0. Why do we need to know these two theorems? Initial conditions and for when t approaches to 0. And how about t approaches infinity?
At the final stage, final.
Yes, we want to check our system, how the system behaves at 0 time or when we are at infinity. And sometimes we need to check the system whether our answer is correct or no. Okay, we want to know whether the system predicts correctly or no. That's why we need these two theorems. For this first one, there is an assumption. We say that f of t has no impulse functions. And for the second one, there is a restriction. We say this theorem is valid only if the poles of f of s, the poles, when I say the poles means
The bottom ones are 0.
0, yes, lie in the left-hand side of the S-plane, except for a first order pole at the origin. Why? This is out of the scope of the class, but I say whenever you want to solve, this is a very important restriction because we are looking for a stable system. If the poles of f of s lie in the right-hand side of the plane, so our system will be unstable. So we get unstable response. That's why we are looking for the poles of f of s lying in the left-hand side. For example, if you want to check the initial value we have f of s, and we want to check the initial value for f of t. So this is our function, and this is the inverse Laplace, inverse transform of this function over here. We did it before. So check the initial value using this theorem. I give you 1 minute time. Okay, for example, you have this function, and the question is, check the initial value for this one. If you want to check whether, for example, your inverse transform is correct or no, this is one way. Lim s of s times f of s when s approaches infinity must be equal to lim of f of t when t approaches 0 positive.